so mad. My husband left me to go out of town for work.
Oh my god, the same thing happened to me. Now we can have some real fun.
I know, let's go gambling.
Last step.
You're right, we don't need those.
Wait, before we start gambling, we need to figure out probability.
Okay, you're right, let's practice.
What's the probability of getting a king of hearts or a queen of clubs?
Wait, call that a clover. It's so much cuter.
The probability of getting a king of hearts or a queen of clubs, queen of clovers, would be 2 out of 52 because there's only one particular king of heart and there's only one particular queen of clubs. So added together, that would be 2 out of all of the 52 cards, reduced down to 1 out of 26.
So what's the probability of drawing any face card?
The probability of getting any face card means we have to look at all the face cards found in every single suit. And since there are 4 suits and 3 sets of face cards for each suit, there would be 12 face cards total in the whole deck of 52 cards, which means that's 3 out of 13 when reduced.
Wait, what about dice though? We should try to figure something out with that.
Okay, so what's the probability of getting a prime number with 2 dice?
Okay, let's figure out all the combinations that we could add up to get a prime number.
Since 2 is a prime number, the first one is 1 and 1. The second combination is 1 and 2.
The third combination is 1 and 4.
The fourth combination is 1 and 6. The fifth combination is 2 and 1.
The sixth combination is 2 and 3.
The seventh combination is 2 and 5.
The eighth combination is 3 and 2.
The ninth combination is 3 and 4. The 10th combination is 4 and 1. The 11th combination is 4 and 3.
The 12th is 5 and 2. The 13th is 5 and 6.
The 14th is 6 and 1. The last combination is 6 and 5.
So that's 15 total ways of getting a prime number out of 36 possibilities. Oh my gosh, we should play poker.
We totally should. And if we make enough money, we can leave our husbands.
That would be so nice. I hate my husband.
This is where the big shots play, like us.
Hey girl, what does that mean in poker? I don't know.
It's a flush, duh! A flush is 5 cards of the same suit. It's really rare.
Come on, it can't be that rare if you got it.
Let me show you how rare this is.
There's no way that we got so lucky to get something that's so rare. So let's figure this out. We would have to get 1 card of 1 suit. Since there's 13 cards in a suit, it would be 13 out of a total deck of 52 cards. Now, if we take one of the cards out, that means one of the cards in the total deck is gone, so we only have 51 cards. And one of the cards in the suit is gone, so we only have 12 cards left in the suit. So we would have to do 13 over 52 multiplied by 12 over 51, and we would continue on with 11 over 50, and continuing on with 10 over 49, and continuing on with 9 over 48. And we're multiplying each one because we're looking for ands here. We want 1 card of the same suit and another card of the same suit and another card of the same suit. Well, you get the picture. So basically, we have this formula here, and if we multiply it all out, we get, oh my gosh, 0.000495. Okay, she's totally right. It is rare.
You know what's even more rare than a flush?
What can be more rare than that?
What's more rare is a straight flush. So, should I get rid of this card and hope that I get a 10 of diamonds? If I get another diamond, I'm gonna be in the same boat. If I get a totally different card, I'm gonna lose all my money. But if I get a 10 of diamonds, I'm gonna win $3 million.
If you win all that money, we can definitely leave our husbands.
Let's figure out the probabilities of these three situations happening before we get too excited.
Okay, let's figure out the probability of getting a 10 of diamonds. Because if we get a 10 of diamonds, we win a straight flush and we get $3 million. So, first, remember, there's only one 10 of diamonds in the entire deck. So, the number at the top that we have is 1. But what's the denominator? Now, remember, we already have an ace of diamonds, so that means we take that card out and we only have 51 cards. We already have the king of diamonds, so we take that card out when we have 50 cards. We have the queen of diamonds, which means we have 49 cards, and the jack of diamonds, which means we would have 48 cards. Also, remember, when we give back the 4 of diamonds, we can't get it back, so we shouldn't count that card either, which means we only have 47 cards left to choose from. This means the probability of getting a 10 of diamonds in this situation would be 1 out of 47. Now let's figure out the probability of getting any diamond. Getting any diamond would mean that we still have a flush, which means our situation didn't get any worse and it didn't get any better. So, remember, we still have only 47 cards to choose from because we took out 5 of the diamonds. But because we took out 5 of the diamonds, we only have 8 diamonds left to choose from because 13 minus 5 is 8. Which means the probability of getting any diamond and remaining in a flush would be 8 out of 47. And finally, let's figure out the probability of getting any card except a diamond. Getting any card except a diamond would mean that we would lose all of our money and we wouldn't have a flush anymore, let alone a straight flush. So the best way to figure this out is to leave the probability that we found out for getting any diamond, which was 8 out of 47, and do the reciprocal of that. So that means we would do 1 minus 8 over 47, which would give us 39 over 47. And that would be the probability of getting any card except a diamond. So let's figure out what happens. Let's see if she gets into a worse situation, which is the most likely thing to happen, if she gets into a same situation by getting another diamond, or if she wins $3 million by getting the 10 of diamonds. Let's see.
Go shorty, it's your birthday. We gon' party like it's your birthday. We gon' sip, it's your birthday. And you know we don't give up, cause that's your birthday.
Since I'm so rich now, let's go play blackjack so you can get rich.
Okay, do you know how to play that game?
No, can you teach me?
So the point is that you have 2 cards to start out with, and you have to get as close to 21 as possible. So like if the dealer gives you a 3 and a 4, you have 7, and you decide, should I get more cards or not? So if we're playing against the dealer, it's either person who gets to 21 wins, or the closest to 21 wins. However, if you go past 21, you lose.
Okay, I think I got it. Let's play. Help me, what do I do? I have a 6 of clover and a king of spades.
The dealer has a 4 of hearts and a king of hearts.
Thinking about this scenario, first we need to figure out what is the chance of you busting on your next card.
So I would only bust if I got anything between a 6 and a king.
So the probability of busting, which means we would have a total number of over 21, would be adding up all of the cards that are between 6 and king. And since we only have 3 6s left since we used 1 6, and 2 kings left since 2 of the kings are being used, we have a total of 29 cards left out of the 48 which are not being used.
So did you know that the dealer has to go again because he has 16 or under? That's the rule. If he has 17 or anything above that, he doesn't have to go. But right now, he's forced to go.
So what's the probability that he'll have to go again even after he gets another card?
The only way that he'll be forced to go again after he gets another card is if he gets 16 or under. So the only way that would be is if he gets a 2 or an ace.
This means the probability that the dealer will be forced to draw again would be 4 out of 48, since only drawing an ace or a 2 would force him to draw again, and none of the aces or the 2s have been used, so we can include them all, which means 4 out of 48.
I don't want him to stay in the game. I want him to burn so I can win. Okay, so now's the real question. What's the probability that he's gonna draw another card and he won't bust?
So I was thinking the best way to figure this one out is to figure out the probability that he will bust, and then do the reciprocal by doing 1 minus the probability that he'll bust.
That seems easy. What a good idea.
To find the probability that the dealer will bust, we will have to look at all the cards between 8 and king.
So the probability that he'll bust is if he gets any of these cards. And since 2 kings have already been drawn, we only have 2.
All of these cards add up to 22 over 48, since 2 of the kings have been used.
So this is what we want, the probability that he'll bust. But then to figure out the probability that he won't bust, we'll have to figure out the probability of him getting 21 or getting anything under that. So that's all of these cards here.
Now, in order to find the probability that the dealer will not bust, is to find the probability that he'll either win or he'll stay in the game, which means we can just do the reciprocal of him busting, which means we just do 1 minus 22 over 48, which equals 26 over 48. So there's a 26 out of 48 chance that the dealer will stay in the game or win.
So after learning all this, are you still gonna draw a card?
Well, why not, huh?
Don't be mad at me. I'm the one who has to go back to my husband. Ugh.
That's life. That's what all the people say. You're riding high in April, shot down in May. But I know I'm gonna change that tune.